Yeah. Good evening, children. Good evening, online students.
Good evening.
Good evening. Yeah, who can share the answer for this one? What are the factors of this expression? No, if we haven't done, we'll do it now. We haven't finished this. Yeah, please write now. Anirudhan, what is the sum? Meaning, what is the sum? What is the product?
Ma'am, the sum is 47. Ma'am.
No, not 47. What is the sum? What is the sum?
Minus 47.
Minus 47. And what about the product?
5 root 3. Ma'am.
No. Sorry? 6 root 3. No x square. 6 root 3 into 5 root 3. Very good. 6 root 3 into 5 root 3. So that is 6 5s are 30. Root 3 into root 3 is 3. So 30 into 3, 90 is the product. See here. 6 root 3 x square minus 47x plus 5 root 3. It's very simple. Look at the board. Look at the screen, children. See, just remove this x square and x. This one is the sum. The product is this into this. This into this is the product. But sometimes there is nothing here. It's only x square. That means there's only 1 there. That means there's only 1 there. So it is 1 into, it's 1 into, okay, let me put it like this for you. 1 second. I'll just tell you a general form. Suppose, see, it will be, the given expression will be of the form ax square plus bx plus c. There will be one x square term, one x term, and a constant. Okay, when you're given a quadratic expression, it will have 3 terms. If you have to factorize the expression by splitting the middle term, there'll be 3 terms. One x square term, one x term, and then the constant. So it's of the form ax square, the x square term, plus bx, the x term, and c, which is the constant. All right. So the sum is the b term plus b, and the product is a into c. A into c is the product. The coefficient of x is the sum. The coefficient of x is the sum. The product is the product of x square, the product of the coefficient of x square and the constant. So x square, if it has a coefficient, that one, and the constant, the product is the value for the product. So you can see here minus 47 is a sum. And the product will be the coefficient of x square, 6 root 3. 6 root 3 into 5 root 3, 90. Now, how do you find the two numbers? Let's find the factors of 90. Let's find the factors of 90. So 90 is going to be 2, 45, 3, 15, 3, 5, and 5, 1. So 90 is equal to 2 into 3 into 3 into 5, correct? Now, since the sum does not have a surd, the sum does not have a surd, like the sum does not have any root 3 or root 7 or root 5. So like you remember in one question we wrote 5 or some other number as root 5 into root 5. You remember that? That is when the sum has a surd, when the sum is a surd. Like if it is minus 47 root 3 or minus 47 root 5, then we'll have to split the number like this. 3 as root 3 into root 3 or 5 as root 5 into root 5. But here, what is the sum? It's just minus 47. So now you need to group the numbers so that you get 47 as a sum. So group and tell me what are the numbers? 5?
Minus 45 and minus 2.
Minus 45 and minus 2. So see, correct. So we'll group all these 3 numbers and have this separately. So what will this give you? 45. This gives you 45 and this gives you 2. So 45 and 2, when you add, you'll get 47. Now fix the signs. Minus 2 and minus 45 will give you minus 47 and the product is plus 90. I told you you'll have to use all these factors. You need to use all these prime factors and make two numbers. In any order, you can multiply them and make two numbers so that you get the sum as 47. So 2 and 45, then fix the signs. So how do you split the middle term? 6 root 3 x squared minus 2x minus 45x plus 5 root 3. Plus 5 root 3. Now, what's common between these two? What's common? Between 6 root 3 and 2. What is common? 2 is common. 2 is common. And between x square and x, x. 6 root 3 and 2 is common. 2 is a HCF. X square and x, x. Open bracket. Now 2x, 3 root 3. 3 root 3. Yes. Because 2 into 3 root 3 is 6 root 3. And x. Minus 1. Correct. Then put this minus sign as it is down. This minus sign as it is comes down. If it's plus, it will be plus here. With minus here, it's minus here also. Now, what is common between these two?
5.
One minute, I'll just help you. 1 second. I have to be very careful here. We're trying to find what is common between 45 and 5 root 3, correct? What is 45, children? 45 is what? 3 3s are 9. 9 5s are 45, correct? 45 is 3 3s are 9, 9 5s are 45. And this is, yeah, now what's common?
5 root 3.
No. This can be written as root 3 and root 3, no? So what's common? 5 root 3 itself is common. Okay, we'll do it again. We'll do it again. You must write the factors to understand that. 45 is 3 3s are 9, 9 5s are 45. Is this correct? And 5 root 3 is 5 into root 3. 5 into root 3. Now, this is further. This 3, one of the 3's can be written as root 3 into root 3, correct? Then that into 3 into 5 as it is. Now, come check. What is common? There is root 3 here, there is root 3 here. There is 5 here, there is 5 here. So that means there is 5 root 3. 45 has 5 root 3 in it. So the common factor is 5 root 3. The HCF is 5 root 3. Open bracket. Now 5 root 3 into what will give you 45? What was remaining here? Yeah, what was remaining here? How much? 3 root 3. What was left over? Whichever factors are left over, just multiply them. 3 root 3. See, 5 root 3 is common. No, 5 root 3 is common. So the remaining factors, 3 root 3. Correct? No, sorry. No, 3 root 3 is 3 root 3. 3 into 3 is 9. 3 into root 3 is 3 root 3. Yeah, so Bhavishya said she's taking it up online. I forgot to share the link with her. Yeah. No, did somebody say something? Yeah. True or false? Yeah, you have to wait. Or if you're going on your own, you can leave. Yeah, bye. Yeah, children. So 3 root 3, right? 3 root 3 x. 3 root 3 x. Yeah, then minus into, yeah, Santosh. Oh. You have a phone with you? No. If you, yeah, you can make a call. There's a phone on the wall there. If you're dialing a mobile number, prefix 0. If you're dialing a mobile number, 0 and followed by the 10 digits. Minus into minus is plus, children, correct? Minus into minus is plus 1. because minus into minus plus, and 5 root 3 is common outside. So 1. Okay. So that's going to be 2x minus 1 into 3 root 3 minus x minus 1. Yeah, right on.
2x minus 5 root 3, ma'am.
So sorry. 2x minus 5 root 3. Yeah, yeah. 2x minus 5 root 3 into 3 root 3x minus 1. These are the two factors, right on? I'm writing, children.
Completed, ma'am.
Good evening, Bhavishya. I'm sorry, I forgot to share the link with you. Done writing, children? Done, all of you? No, but somebody will come to take you, right? Yes, children, try the first one. Yeah, somebody's come to take you? Yes. Okay, bye. Yeah. The first one. I'll tell you how to start, okay? Then you'll do it by yourself. Now, replace x plus y with a. X plus y with a. All right. So you start like this. You say for the first one, okay? Let x plus y be equal to a. Now rewrite the given expression. Rewrite the given expression. So it will be 2a square minus 9a minus 5. Now this is a quadratic expression. So we factorize this by splitting the middle term, sum product. What is the sum? Minus 9. What's the product? 2 into minus 5, which is minus 10. Yeah, complete this, and then once you find the two factors, in place of a, you replace x plus y. That's all. Once you find the two factors, in place of a, you replace x plus y. That's it. Completed.
Done, ma'am.
Yeah. What are the two factors? What are the two numbers?
I'm like, after replacing A or before replacing with A?
No, here, after this step, product is minus 10. So it's minus 9 and
2A
minus 10 and plus 1.
1, ma'am.
Very good. Minus 10 and plus 1. Now, what are the factors? Before substituting, what are the factors?
2A plus 1 into A minus 5, ma'am.
Okay, I think some of them are still working here. Finish it. Two A plus minus 1. A minus 5. Swati, 2A plus 1 and
A minus 5, ma'am.
A minus 5.
Yes, ma'am.
Okay. 2A. Yeah. So see here. You can see that here. A minus 5, 2A plus 1. Now replace. What is A actually? X plus Y. So instead of A, X plus Y minus 5 and 2A. So 2 into X plus Y plus 1 plus 1. So it will become 2 into X, 2X, 2 into Y, 2Y. 2X plus 2Y plus 1. Replace A with X plus Y. Replace A with X plus Y because we have assumed X plus Y to be A. Somebody's come to take you? Yeah. Yeah. One sum left. Huh? Okay. Finish it. Yeah. You can't see? No, I think the father will come inside, no? So don't worry. If you want, you can go near the door, check and come back. Yeah. See you. So this till here you understand. Now after this, you need to replace A with X plus Y. So it will be X plus Y minus 5 and here 2 into X plus Y because 2A. So 2 into X plus Y plus 1. So when you multiply 2X plus 2Y plus 1. Finished? Aniruddhan, finish writing this? Bhavishya? Okay. This is the next one. I'll show you the answer slide also. So sometimes when, you may also have to factorize by grouping. Okay, sometimes you may also have to factorize by grouping. So see here, you may have to rearrange the terms also in group, but I'll just tell you how grouping works. So you can see that you can factorize this expression by grouping the first two terms and the last two terms. Group the first two terms, group the last two terms. So between the first two terms, what is common?
X.
Between the first two terms, I don't know why I've written this step again. Don't have to write this. Yeah. Group the first two terms. So X is common. So x squared plus 1 in the bracket, because x into x squared is x cubed, x into 1 is x. Then always put the sign as it is, minus as it is. Now between this term and this term, 3 is common. So 3 outside. 3 into x squared is 3x squared. Minus into plus is minus. 3 into 1 is 3. Correct? That's all. Then x squared plus 1, x minus 3. Write down. Two point three. There's one more. Huh? Done. So there's just grouping the first two terms and last two terms. Sometimes you may have to rearrange the terms and then group. You can help yourself till here. After that, I'll explain. Till here, you can work. After that, I'll explain. shared the previous class recording with you. Watch that and write down the notes in your book. Okay, I'll send you notes. All right. So how is this worked? We first have to take the common denominator. So 35 is the LCM. So common denominator 35. So this is like 1 here, no? So 1 into 35 is 35, correct? So into 35 in the numerator, LCM. Here it is into 1. So numerator also into 1. Here also into 1 is 35. So into 1 in the numerator, correct? LCM. So 35 is the common denominator. So this is 1. So it is 1 into 35 is 35. So that into 35 here. So 35x square. Then plus 12x plus 1. Because here it's into 1, into 1, into 1, into 1. So 12x plus 1. So that's the first step. Common denominator is the first step. 35x squared plus 12x plus 1 by 35. Now split the middle term. In the numerator, ignore the denominator. The denominator is 35. Just leave it alone. Look at the numerator. The numerator is a quadratic expression. So there, sum, product, find the two numbers, split the middle term. So the sum is, you can write the sum and product in the rough column. What is the sum? 12. And the product is 35 into 1, 35. 35 into 1, 35. So the two numbers are 7 and 5. 7 plus 5 is 12. 7 5s are 35. So split the middle term and then you know the step. So denominator, we're not making any change. Only the numerator. So split the middle term, then grouping, and then the step. So till here, you're familiar with that. Now after this, because you need to write the answer as the product of two factors. So sometimes they'll give you this question. MCQ, it will be like the two factors of this one are, and they'll give you these two. The two factors of this one are, they'll give you two factors, A, B, C, D, two factors, and one of the option will be this one, x plus 1 by 7 and x plus 1 by 5. So this is the correct option. So you should know how to bring it to this step. All right. So now 35, this is 35. All right. So now since there is a 7 here and there's a 5 here, we just, like decompose 35 as 7 into 5. 35 is 7 into 5. So what we do, we write this numerator, this numerator separately and divide this one by 7 and this one by 5. It's the same, no? See, this into this is the numerator here and 7 into 5 is 35, the denominator. You cannot put 35 for both. See, supposing it was, I'll tell you the difference. See, supposing it was A plus B by 35. Then it will be A by 35 plus B by 35. When it is A into B by 35, it cannot be A by 35 into B by 35 because A into B is AB, but 35 into 35 is 1225. It's a different value. A plus B or A minus B by 35 can be written as A by 30. See, when it is plus or minus, it can be written as A by 35 plus or minus B by 35. But when it's multiplication, this can be written as A by 7 or 5, whatever you want. 5 or 7, whatever you want. Because 35 is what? 5 7s are 35. So you can write A by 7 into B by 5. Or you can write A by 5 into B by 7. Because A into B is AB and 5 7 are 35. That's what we've done here. But here we are more choosy. There's this one has 7x plus 1. There's 7 here. So this one divided by 7 into this one has 5. So this one divided by 5. Now what is 7x What is 7x plus 1 by 7? How can you write this? This is 7x by 7 plus 1 by 7. So that's what in the next step. And what is 5x plus 1 by 5? 5x by 5 plus 1 by 5. Yeah, that's what we have done in the next steps. Okay, so this one and then, yeah, this one. So now 7 and 7 gets cancelled. So you have x plus 1 by 7 into 5 and 5 cancels, x plus 1 by 5. All right. Take down, children. If you have not finished, please finish it. If you have finished, we can go to the next one. You want to make a call or something? Do you want to make a call? Done writing, children? Aniruddhan, Swati and Bhavishya, finished writing?
Last step, ma'am.
Done, Swati?
Completed, ma'am.
Yeah. Try this one.
Done, ma'am.
Finished?
Yes, ma'am.
Yeah. Read out your steps, Swati.
Ma'am, first I have found the sum, ma'am.
Yeah.
And that is minus 2 root 2.
Okay.
And then followed by the product, which is minus 30.
Okay.
And then I have found the prime factors of minus 30, which is
Okay.
5
No.
into 3 into
Okay. Okay. Fine. 30 is equal to?
5 into 3 into 2, ma'am.
Okay.
And then I have written this 2 as root 2 into root 2
Very good.
into 3 into 5. And then found the numbers as 5 root 2 and 3 root 2. And then
Very
fix the sign to minus 5 root. Fix the minus sign to 5 root 2 and plus sign to 3 root 2.
Very good. Very good, Swati. Okay. So the required numbers are minus 5 root 2 and plus 3 root 2. Because the sum has root 2 in it. The sum is 2 root 2. It's a surd. There is root 2 in it. So 30 is 2 into 3 into 5. 2 should be further written as root 2 into root 2. And this is very easy because the other numbers are 3 and 5. So one number will be 3 root 2. The other will be 5 root 2. Both the numbers must have root 2 in it. Only then you can add and get root 2 as a result. Both the numbers must have root 2 in them. Only then you can add and get root 2 as a result, meaning something root 2. So it is 5, so it is 3 root 2 and 5 root 2. Then fix the signs. Okay. So x squared, yes, Swati, continue. X squared.
X square minus 5 root 2x
Yeah.
plus 3 root 2x minus 30, ma'am.
Okay.
Ma'am, and then finding the common factors, we get x into x minus 5 root 2
Okay.
plus.
Yeah. Let me ask the class also, Swati. 1 second. So children, tell me the factor of 30. We're trying to find what is common between 30 and 3 root 2. What is common between 30 and 3 root 2? Okay. So 30. 30 is what? 2, 3 are 6, 6, 5 are 30. 2 into 3 is 6, 6, 5 are 30. And this 2 is further. This 2 can be written as root 2 into root 2 into 3 into 5 into 5. And what is 3 root 2? 3 into root 2. So what is common? 3 and root 2. 3 root 2 is common. See, both of them have, see, 3 root 2, 3 root 2. So 3 root 2 is common. 3 root 2 is common. Open bracket. So 3 root 2 is common. Then x, correct? Minus into, what's the sign here inside the bracket?
Minus plus
Minus.
3.
Minus. Plus into minus is minus. Now 3 root 2 into what is 30? What are the remaining factors?
5 root 2.
5 root 2. What are the remaining factors? 3 root 2 is common. So the remaining factors are 5 root 2. So 5 root 2. 5 root 2. Am I clear to everybody? All right. So now x minus 5 root 2 into x plus 3 root 2. Very good, Swati. Why no response from Bhavishya and Aniruddhan? This is actually 8th standard. Let's see if you can recall. Try.
Done, ma'am.
Done? Okay.
Yes.
I'm done, ma'am.
Okay, Bhavishya, read out your answer.
Ma'am, I have 25x square minus 10x plus 1 minus 36y square. For 25x square and minus 10, common is 5x. 5x into 5x minus 2 plus 1 into 1 minus 36y square. 5x
No, no,
minus 2
darling.
into 5x.
No, 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 no. It's not like that. No. Swati?
Ma'am, first I just regroup 25x square minus 10x plus 1 minus 36y square, and then using the identity we can, it is in the form like x square minus 2xy plus y,
Yeah.
and then 25x square can be written as 5x to the whole square, and 1 can be written as 1 square, and then for 2xy we can write it as 2 into 5x into 1. And then after the answer of this identity would be 5x plus 1 the whole square minus
5x
36
plus
y square.
1.
I mean
5x
5x
plus 1 the whole.
minus 1 the whole square
Hmm.
minus 36 y square, ma'am. And this is
Yeah.
of the form a square minus b square.
Correct.
And then a square minus b square is a plus b into a minus b. Then it would be 5x minus 1 minus 6y into 5x minus 1 plus 6y.
Very good. Very good, Swati. You're right. All right, children. No problem. If we don't, we are not able to recall, it's okay. So see here, 25x square plus 1 minus 36y square minus 10x. Okay. You need to first rearrange this. How? 25x squared. Now this, look at this. This is y square, but look at this one. It's 10x. So 25x square and minus 10x. 25x square is like that a square term. The 10x is like the 2ab term. So now we want a b square. That b square cannot be 36y square, because if b square is 36y square, then the middle term should have y also in it, right? The 2ab should have y. And the other thing is the b square is all, see, whether it is a square plus 2ab plus b square or a square minus 2ab plus b square. See, this is plus b square always, plus a square. The middle term only can take different signs, plus or minus. The a square and b square terms are always positive. Look at the identity. A square plus 2ab plus b square, or a square minus 2ab plus b square. A square and b square are always positive. It's only the middle term 2ab that can be plus 2ab or minus 2ab. So, in that sense, 36y square is minus 36y square. So it cannot be the a square term or the b square term, because it is minus 36. Minus 36y square. It's minus. A square and b square terms are positive. But why are we calling that the a square or b square term? Because it is a perfect square. 36y square is 6y the whole square. 6y the whole square. But since it's negative, it cannot be a square or b square. So 25x square is positive. So a square. And because 25x square has an x there, the 2ab can be minus 10x. Plus b square. Plus b square cannot be this. It has to be plus 1. So that minus 36y square stands alone. Now these three terms go to make a square minus 2ab plus b square. 25x square is a positive term. Positive perfect square. See here, 25x square is positive and it's a perfect square. So it's like a square. Now b square also should be positive. B square also should be positive. But these terms are negative, no? So this is positive. Even if this was positive, it's not a perfect square. So the b square term is plus 1. And the middle term, the 2ab term, can be minus 10x only, because the a square term has x in it. So the middle term should have x. So these three terms go to make a square minus 2ab plus b square. Okay, so this is equal to okay. So these three terms, there's nothing but 5x the whole square, and this is nothing but plus 1 the whole square. So the middle term is minus 2 into 5x into 1, correct? Which is 10x minus 6y the whole square. Now what is this? A square minus 2ab plus b square, a minus b the whole square, 5x minus 1 the whole square, minus 6y the whole square. Now this is like a square minus b square, a plus b into a minus b. So a plus b plus 6y into a minus b minus 6y. This is how we factorize. These are the two factors of the given expression. Yeah, right on. Done, children?
Done, ma'am.
Yeah. This is simple. Now you can see some expressions, they are common, no? 2a plus 3b, 2a plus 3b, 2a minus 3b, 2a minus 3b. So let's replace it with x and y. Let 2a plus 3b be x. Then 2a minus 3b be y. So what is the given expression? It's x square plus 2xy plus y square. What is x square plus 2xy plus y square? X plus y the whole square. It's x plus y the whole square. Now replace. What is x? 2a plus 3b. And what is y? 2a minus 3b. X plus y the whole square. So minus 3b plus 3b gets cancelled. 2a and 2a is 4a. 4a the whole square, which is 16a square. This So if this was minus here, then it will be x
square
minus.
2x.
So it will be x minus y the whole square. So here it will be minus. So when you open the bracket, it will be 2a plus 3b minus 2a plus 3b. Minus 2a plus 3b. When you open the bracket, it will be minus 2a plus 3b. So 2a and minus 2a will get cancelled. 3b plus 3b, 6b. 6b the whole square is 36b square. So the bracket is very important. This even if now because it's plus, even if you don't put the bracket, you will get the correct answer. If it is x minus y the whole square, x in one bracket, y in another bracket, separated by a minus sign. So when you open the bracket, it will be minus 2a minus into minus plus 3b. Whenever we have more than one term, we have to enclose them in a bracket. Whenever we have more than one term, after the minus sign, you know, something minus something. Okay, now after the minus sign, if you are going to write more than one term, you must enclose. So more than one term meaning 2 or 3 terms, you have to enclose them in a bracket. That's all. That's a simple rule. Before the minus sign, you put a bracket, you don't put a bracket, you will not make any mistake. But when there's a like x minus y, x, you substitute something for x minus y. Now this y, if it has more than one term, minus, and then in the bracket, you must write that y term. Now you should remove the bracket in the next step because that minus is applicable to every term inside the bracket. So when you remove the bracket, that minus should be multiplied with every term inside the bracket. So the signs will change. Like here. So if this is x, if it's minus, it will be minus here. Why you should not write minus 2a minus 3b like this? You must put minus and in bracket y, because y has more than one term. Y is 2a minus 3b. It has more than one term. So we should put in a bracket. Now next step it will be open the bracket minus 2a minus into minus plus 3b. Okay, so now I'll just recall the division of polynomials for you. Okay. If you have not learned the division or if you have forgotten the division process, listen carefully now. Now you can see that the dividend is cubic, is a cubic expression because the highest power is 3. The highest power is 3, so it's cubic. Look at the divisor, it's linear because the power is 1. The power is 1. The divisor is linear because x is raised to the power 1. Okay, so the divisor is linear while the dividend is cubic because the highest power of the variable x is 3. So it's a cubic polynomial. Now we're going to divide these two. Now the first term in the quotient will be, now very important is you need to arrange the terms in the ascending or the descending order of their powers. So we normally arrange it in the descending order. So see here, power 3, power 2, power 1, that is x to the power 3, x to the power 2, x to the power 1, and then the constant. You must arrange the terms in the descending order of the powers. That is, if there's power 7, x power 7, then supposing 6 is not there, it's okay. But then if it is x to the power 4, next 4, then x cubed, then x. All right. So supposing it's jumbled, you know, you have x to the power 4, then x cubed, then x to the power 7, and then x. You should not write the dividend as it is. You must arrange the terms of the dividend in the descending order of the powers, big to small. Even in the divisor, in both the divisor and the dividend, the terms must be arranged in the descending order of the powers of x. So see here, x to the power 1 first and then the constant 5. If it is 5 plus x, you should not write it like this. You must write x plus 5. Okay, so that's very important. Arranging the terms is very important. After arranging, now the first term, divide this one by this one. That is, divide the first term of the dividend by the first term of the divisor. First term of the dividend by the first term of the divisor. X cubed divided by x is x squared. Correct? That is the first term in the quotient. That is the first term in the quotient. Now multiply that first term, whatever you get in the quotient, by the divisor x plus 5. By the divisor x plus 5. It's called alternative. So yeah. So first step, x cubed by x, which is x squared. Now you should multiply x squared with the divisor, which is x plus 5. X squared into x plus 5. What do you get? X squared into x is x cubed and 5x squared. That's what you should write below here. X cubed plus 5x squared. All right. Now, division is always subtracting. So you have to change the signs. Even when you divide a number by another number, you will subtract, no? So you should subtract, change the signs. You have to change the signs. Plus becomes minus, plus becomes minus. X cubed minus x cubed gets cancelled because 0. Plus x cubed minus x cubed is 0. So they get cancelled. Plus 2x squared minus 5x squared. Take the new sign. Forget the original sign. Take the new sign. 2x squared minus 5x squared is minus 3x squared. Now bring the next term down. You can bring, in fact, you can bring all the terms also down. You can even bring all the terms down. Now continue. Divide the first term. This is called the new dividend. This is called the new dividend. Dividend. This is the divisor. Now divide the first term of the new dividend. This is called the new dividend because this is the dividend. This is the dividend. Now this is the new dividend. Divide the first term of the new dividend by the first term of the divisor. So minus 3x squared. This is the first step. This is the second step. That will be minus 3x squared divided by x, which is minus 3x. That's the second term in the quotient. Minus 3x is the second term in the quotient. Now multiply that minus 3x with the divisor x plus 5. With the divisor x plus 5. So you'll get minus 3x squared minus 15x. Correct? So write out that here. Write that here. Minus 3x squared minus 15x here. Again, subtract. So you'll have to change the signs. Plus becomes minus becomes plus. Minus becomes plus. Minus 3x squared plus 3x squared. 0. Gets cancelled. Minus 25x plus 15x. Minus 10x. Comes down. You don't put arrows and all that. Okay, I'm just showing you. You don't use arrows. Don't use the arrows. Now minus 50. Correct? Now this is again the new dividend. This is again the new dividend. This is the first new dividend. This is the second new dividend. That's the first new. This is the dividend. This is the dividend. This is the first new dividend. This is the second new dividend. Divide that. So divide the first term of the second new dividend, that is minus 10x, by the divisor x. So you get minus 10. Minus 10. Now multiply minus 10 with the divisor x plus 5. And that gives you minus 10x minus 50. Write that here. Minus 10x minus 50. Correct? Change the signs. Plus minus 10x plus 10x, 0. Minus 50 plus 50, 0. So we say that the dividend is a multiple of the divisor, or the divisor is a factor of the dividend. Because what do you get when you divide 56 by 7? 7 8s are 56. 0 is the remainder. When the remainder is 0, what do you say? 7 is a factor of 56. 56 is a multiple of 7. In the same way here, since the remainder is 0, the dividend is a multiple of the divisor, or the divisor is a factor of the dividend. So supposing they give you these two expressions, and if they ask you, is the dividend x cubed plus 2x squared a multiple of the divisor, then you should perform the long division. And if the remainder is 0, yes, it's a multiple. If the remainder is not 0, no, it's not a multiple. You're right on this?
Does the thought like if the questions that x to the power 4 plus x squared plus x and plus 1 it was
0. Add 0. It's okay if you don't add 0.
it was normal cases I was spiral division also.
No, that's called synthetic division. இப்பதான் நான் ஆரம்பிச்சிருக்கேன். அது நெக்ஸ்ட் சொல்லி தரேன். Yeah, 0 போட்டாலும் அதே ஆன்சர் தான் வரும். Long steps in that. You're a 9th standard, you don't have to write all that. அதான் எழுதவே வேண்டாம். அது எழுதாமே will get the answer. Finish writing? Done writing, online students?
Yes, ma'am.
Completed.
Okay. Yeah. Yeah. Now we'll see what is called the. Have you all watched that introduction video which I sent on polynomials, where I had explained all the identities? All identities were explained there. All the identities for 9th standard were explained there, and I had done one sum of every kind, I think. One sum of every kind I had explained there. Yeah, now don't think I didn't teach you all the identities. It was all in the videos. Okay, now let's understand what is this remainder theorem. Remainder theorem. Now we use this remainder theorem to find the remainder when a polynomial is divided by a linear factor, only by a linear factor. Using the remainder theorem, so we see how does the remainder theorem work. We'll understand that. Now, when is the remainder theorem used? When can you use it? In what? The dividend can be a polynomial of any degree more than 1. The dividend polynomial can be of any degree more than 1. The divisor polynomial must be of degree 1 only to use the remainder theorem. To do this division, anything by anything you can divide. You can divide, like if this is x to the power 7, you can divide by x to the power 4 also. This division, the degree of the remainder can be 7, the degree of the divisor can be 3, you can divide. Here it's fine. But if you want to use the remainder theorem, now why is the remainder theorem used? The remainder theorem is used only to find the remainder, not the quotient. You will not, now when you perform the long division, like this, you will get both the quotient and the remainder. These are the different parts of division, right? When you divide one expression by another expression, it will produce a new expression called the quotient and another thing called the remainder. That's all. Nothing else we have from a division process. We have nothing else from a division process. From a division process, so to start or to initiate a division process, you need a dividend and divisor. With that, you can initiate a division process. And once you do perform it, finally you will have one quotient and another remainder. That's all. So this long division will give you both the quotient and the remainder, but the remainder theorem will give you only the remainder. If you want the quotient, you should do the long division. If you want only the remainder, you can use the remainder theorem, because that will give you the remainder quickly in less time. If you want to know only the remainder out of a division process, you can use the remainder theorem because you can get it quickly. But there are some conditions. You cannot use the remainder theorem for any dividend polynomial and any divisor polynomial. So these are the conditions. Dividend polynomial degree should be degree greater than 1. Divisor polynomial degree 1 only. Divisor polynomial, the degree should be 1 only. That means the divisor polynomial can be like x plus 5, 2x minus 4, whatever, like 2x minus 5, or some y minus 1, z minus 3. See, power should be 1. Power should be 1. Linear polynomial. Divisor, the degree of the divisor should be 1 only. To use a remainder theorem for the long division, anything. And the degree of the divisor dividend polynomial should be greater than 1. Now this one can be done using the remainder theorem, because if you look at the dividend polynomial, the degree is 3, and the divisor polynomial, the degree is 1. Divisor, the degree should be 1 only. Dividend can be anything. Like that you can remember, dividend can be anything, but divisor should be 1 only. So this one we can use a remainder theorem for this one to find the remainder. Okay, so let me write x cube. Read out now. What is it? X cube minus. Okay. So to use the remainder theorem, we need to name the polynomial first. Okay, so let's call this P of x. I told you in one class earlier. This is called P of x because x is the variable. X is the variable, so we'll call it P of x or Q of x, F of x. Okay. In the bracket, what you write should be the variable. Okay. And then Q of x is equal to x plus 5. X plus 5. We can even call it G of x. X plus 5. All right. So they satisfy the conditions. The divisor polynomial degree is 1 and the dividend polynomial anything. So it's 3. It's fine. So now we are going to use the remainder theorem not to find the quotient because we cannot get the quotient. To find the remainder on dividing P of x by G of x. Okay. So for that, take up the divisor x plus 5 and equate it to 0. Take up the divisor x plus 5 equated to 0 and find the value of x. And find the value of x. Take the divisor. You're tired again today, Niveda. Okay, so wash your face, no? X plus 5. Take the divisor, equated to 0 and find the value of x. X is equal to minus 5. Now, in P of x, that is fine. Now find P of 5. P of minus 5. That means in place of x, we used 5, minus 5, sorry. In place of x, we've used minus 5. So P of minus 5 will be the remainder when P of x is divided by G of x. P of minus 5, because x is equal to minus 5. No, see here, in P of x, in place of x, we're using minus 5. Because x is equal to minus 5, no? So in place of x, we're using minus 5. So P of minus 5 will be the remainder when P of x is divided by G of x. Right? So how do you find P of minus 5? Okay. So in P of x, wherever there is x, use minus 5. So minus 5, the whole cube, plus 2 into minus 5, the whole square, minus 25 into minus 5, minus 15. That is in the dividend. In the dividend polynomial, wherever there is x, use minus 5. Now simplify this. Minus 125 because minus 5 into minus 5 into minus 5, minus 125. Then this you'll have to be very, very careful. Do not do plus into minus minus. Do not do that. I told you earlier also. I think that Sunday class I told you this. Do not do that. So plus 2 into what is minus 5 into minus 5? 25. Then here you can multiply plus 125 and minus 50. Now minus 125 plus 125 cancels. So this is now 50. 225 are 50. Minus 50, which is 0. Which is 0. And that's what is the remainder also. We already performed the long division and we know that the remainder is 0. So you need to check if the divisor is linear. Once it is linear, equate the divisor to 0. Equate the divisor to 0 and find the value of x. Now, use this value of x in the dividend polynomial. In the dividend polynomial, wherever there is x, use minus 5. And that will give you the remainder. When you work that will give you the remainder. All right. You don't have to write this. So this is how we use the remainder theorem. The remainder theorem can be used only to find the remainder, not the quotient. And remainder theorem can be used only when the divisor polynomial is linear. If it's quadratic, we'll see how to do it. If it's quadratic, you should find the linear factors and then do it. We'll see that later. Now this is about remainder theorem. Now we'll see how to use a synthetic division. Tell me the synthetic division will give us the remainder and the quotient. Synthetic division will give us both remainder and quotient. Yeah. Tell me what's that?
Plus x square minus 25x minus 50.
Okay. And what's the divisor? X minus 5. X plus. Okay, so E equated to 0. What do you get? X is equal to minus 5. Now here, how many of you have learned this in school? Okay, few of us have learned. Okay, no problem. Now, write out only the coefficients of the dividend. Write out only the coefficients of the dividend. This is the dividend. This is the dividend. Write out only the coefficients. X cube. What's the coefficient? 1. Then there should be if it starts with x cube, there should be the x square term. What's the coefficient? Plus 2. Then if there's any power of x missing, you must put a 0. Now supposing the polynomial is x to the power 7 minus 6x to the power 4 minus 7 x square or 17x square minus plus 11. In this case, you know, x to the power 7, what's the coefficient? 1. Then there should be one x power 6 term. There should be one x power 6 term, but it's not there. So 0. 0 is a coefficient. Okay, 1 minute. If any power of x is missing, you should. Whichever power of x is missing, you must show its absence using a 0. 0 x to the power. You can understand this, right? So x to the power 7, x power 6, x power 5 is missing. So plus 0 x power 6 plus 0 x power 5. Then we have x power 4. Then x power 3 is not there. So 0 x power 3. Then minus 17 x squared. But x term is not there. So 0 x plus 7. So now when you have to use when you have to perform the synthetic division, coefficients 1, 0, 0, minus 6, 0, minus 17, 0, and 11. Let's slowly. The coefficients you must write. You must write only the coefficients. 1, 0, 0, minus 6, 0, minus 17, 0, and 11. Okay. But here we have all the powers of x, x cube, x square, x and the constant. We have everything. X cube, x square, x and the constant. So coefficients 1 plus 2 minus 25, 50. All right. Yeah. Now what's the value of x we got? Minus 5. Minus 5. Yeah. Down off? Okay. So always start with the 0 here and bring down this number as it is. 1 and 0 is 1. Now multiply. Minus 5 into 1 is minus 5. Write that result here. Minus 5. Multiply. See, always start with the 0 here, children. Always start with the 0 here. 1 and 0. Whatever the sign says, you must do. 1 and 0 is 1 when you find the sum. When you find the sum, 1 and 0 is 1. Now, minus 5 into 1 is minus 5. Now, plus 2 minus 5 is minus 3. Now, multiply. Minus 3 into minus 5 into minus 3. Plus 15. Plus 15. Minus 25 plus 15. Minus 10. minus 5 into minus 10 plus 50. Minus 50 plus 50 is 0. All right. So now this is the remainder. This one is the remainder. This one is the remainder when you divide. When you divide this one by x plus 5, the remainder is 0. And the quotient is fixed. See, this is the constant term. This is the x term. This is the x square term. This is the constant term. This is the x term. This is the x square term. So x square minus 3x plus minus 10 is the quotient. X square minus 3x minus 10 is the quotient. And the last number is the remainder. The remainder is 0. See, that's what we got in the long division. X square minus 3x minus 10 is the quotient and 0 is the remainder. So when you use a synthetic division is not a part of your syllabus, but we'll use it to make our work easy. We'll use it in the rough column. This is not new syllabus. This is not a part of the main working. We'll see where we can use this to make our work easy. So we'll do this again. So you need to place the coefficients in an arrangement like this. Remember that if it starts with x cubed, after that you should have an x square term, x term and constant. If any power of x is missing, you should write it with 0. Okay. But here we have all the terms. So x cube, its coefficient is 1. X square, its coefficient is 2. X, its coefficient is minus 25. And the constant is minus 50. All right. So now x plus 5, you want to divide this by x plus 5 equated to 0. So x is equal to minus 5. Write that here. Always place a 0 here. 1 plus 0. See, you have to find the sum of the numbers there. So 1 and 0 is 1. You're not multiplying. You should add or subtract. Whatever the signs say. So 1 and 0 is 1. Now multiply. Minus 5 into 1 is minus 5. 2 and minus 5. Minus sum. Now you should find the sum. Minus 3. Minus 5 into minus 3. Plus 15. Again, minus 25 plus 15. Minus 10. Now multiply. Minus 5 into minus 10. Plus 15. And the remainder is 0. This is the remainder. When you divide this one by x plus 5, the remainder is 0. And the quotient is, this is the constant term. This is the x term. And this is the x square term. So 1x square or x square minus 3x minus 10 is the quotient. So synthetic division can be used to find both the quotient and the remainder. Even if the remainder is not 0, you'll get it here. If supposing you get 7 here, 7 is the remainder. And this is the quotient. So synthetic division can be used to find both the quotient and the remainder. A remainder, this is not a part of your syllabus, but we'll use this to make our work easy in some places. A remainder theorem is a part of your syllabus, which can be used only to find the remainder. Long division, all of you could recall?
Synthetic division is the best one. Yeah, synthetic division, I saw teaching totally different. Because the constant is minus 15 means you take the multiples of minus 15, which is minus 1 and plus 1 and minus 5 and plus 1 and minus 10 and plus 10. And
the other further things are solo. See, if you've learned the chapter completely in school, I've just started with A, and you're asking me why XYZ is not there. I've just started, no? No, I'll finish the chapter and then you can tell me if you've not done something. Yeah, children. Take down the first question. Take down the first question, children. Yeah, let's factorize that. Scroll again. Taking the first question.
Yes, ma'am.
Yeah. All right. So the golden rule in factorization is that whenever the terms have something in common, you'll have to take out the common factor. So what is common? X to the power 2 is common. So in the bracket, x power 6 minus y to the power 6. X to the power 6 minus what happened? Oh, this is correct. X squared, correct? What I've written? X squared into x to the power 6 is x power 8. And x squared into y to the power 6 is x squared y to the power 6. Correct? See, whenever the terms have something in common, you'll have to take out the common factor. So x squared is common. X squared into x to the power 6 is x power 8 minus, because x squared into x power 6. Base the same multiplication, add the powers, 2 plus 6, x power 8 minus x squared is common. So this y to the power 6 inside. Correct? Now this is nothing but x squared, open bracket. This can be written as x cubed the whole square minus y cubed the whole square. Correct? Now x squared. Now this is like a square minus b square, which is a plus b into a minus b. This is like a square minus b square. So a plus b into a minus b. A plus b. Because a square, no, see, this one, this is a square. See, this is a, this one is a square. So this is a. And this is b, and square. So b is this one. So a plus b into a minus b. Now this is further. What is x cube plus y cube? X plus y into x squared minus xy plus y squared. And what is x cube minus y cube? X minus y, x squared plus xy plus y squared. Identity. That's it. We factorize. So these are the factors of the given expression. Right on. Then of course arrange it. Last step I've arranged it. Right on. The last step, I've just arranged the factors. I've just arranged the factors. I've written this one first, then this one, then this one. I've just arranged it. Finished? Vishya, Swati, and Aniruddhan, finished writing?
Done,
Yes,
ma'am.
ma'am.
Okay. Okay. So the question is, for what value of m is p of x, which is given there, divisible by x plus 2? For what value of m is the given polynomial divisible by x plus 2? So we'll understand the question better. So we are given that p of x is equal to x cubed minus 2mx squared plus 16. Okay, so this is like the dividend. And the divisor is x plus 2, x plus 2. Now the question is, what should be the value of this m? Can you see an m here? Can you see an m here? So that means this p of x is not complete. So maybe that m is 3. So 2 into 3, it is 6x square actually. See, that is 2mx square, right? So maybe, what's that you're writing and talking? Answer. Huh? Okay, so maybe it is 6x square. So what is 6x? Maybe it's 6x square. So it is 2mx square, meaning the value of m is 3. Okay, so you need to find the value of m such that p of x is divisible by g of x. See, always name the polynomials given. That's very important. Only then you can read the question better. Now see here, I can read it easily. For what value of m is p of x divisible by g of x? Because I've named it. And where is m? They're talking about m. Where is m? M is here in the dividend in p of x. The question is what value, for what value of m is p of x divisible by g of x? So if p of x should be divisible by g of x, what should be the remainder? 0. Because if it should be divisible, then the remainder should be 0. Yes or no? If p of x should be divisible by g of x, the remainder should be 0. Divisible means exactly divisible. So the remainder should be 0. So now equate, which is the divisor here? X plus 2. Equate that to 0. X plus 2 is equal to 0. So what do you get? X is equal to minus 2. Correct? X is equal to minus 2. Now, which is the dividend? P of x. When you find P of minus 2, what will you get? You will get the remainder. You will get the remainder. When you find P of minus 2, that is in the dividend polynomial. In the dividend polynomial, when you use x as minus 2, you will get the remainder, right? So you will get the remainder. Here you will write, you will get the remainder. P of okay, see, P of minus 2 will give you the remainder. Will give you the remainder. The remainder is 0. Why the remainder is 0? Because it should be divisible. So this is the equation. I always write the equation so that then everything is easy. You should not write the equation. The equation here is P of minus 2 is equal to 0. I'll tell you why again. Why P of minus 2 is 0? We understand the dividend and the divisor polynomial. We understand the dividend and the divisor polynomial. Now the question is, P of x should be divisible by g of x. So we understand that the remainder should be 0. Divisible means exactly divisible. Remainder is 0. Now how will you find the remainder? Equating the divisor to 0, we get the value of x is minus 2. To find the remainder, what will you do? In the dividend polynomial, in place of x, you will use minus 2. That means you will find P of minus 2. That means you will find P of minus 2. Why will you find P of minus 2? To find the remainder. Why will you find P of minus 2? To find the remainder. When P of x is divided by g of x. To find the remainder, you will find P of 2. But you know the remainder. Why will you find the remainder? You know the remainder. It's 0. So this value is 0. This is the equation. So now how will you express P of 2? Where is P of x? X cube minus 2mx squared plus 16. So wherever there is x, use minus 2. So minus 2 x cubed. I'm sorry, minus 2 the whole cubed. P of minus 2. In P of x, wherever there is x, use minus 2. Minus 2m into minus 2 the whole square plus 16 is equal to 0. This value is 0. This is only the remainder. This is how you'll find the remainder. That is 0. So minus 8 minus 2m into minus 2 into minus 2 is plus 4. Plus 16 is equal to 0. So minus 8, what is minus 8m, no? Plus 16 is equal to 0. Minus 8m is equal, okay, what is it? 16 minus 8 is 8. When it goes to the other side, it will become minus 8. So m is equal to minus 8 by minus 8. M is equal to 1. For this only, the value of m is 1. Understand? So when m is 1, okay. So for when m is 1, this condition will be true. That is, P of x will be divisible by G of x. Oh, I don't have the answers. Yeah, right on, children. Oh, I have not written G of x and all that here. So, okay, this is enough. Right on. Please take down the answer, children. Please include this step. Sorry, minus? Plus 16 minus 8 is what? No, that's what. Plus 16 minus 8 is plus 8, right? When it goes to the other side, minus 8. Okay, let me write that step also. Let me write that. So here you will have minus 8m plus 8 is equal to 0. Okay, so since it should be divisible, the remainder must be 0. The remainder must be 0 means you know the remainder. And how will you find the remainder? The divisor is x plus 2, equate it to 0 and find the value of x. X is equal to minus 2. Now in the dividend is called P of x. So find P of minus 2. P of minus 2 will give you the remainder. But you know the remainder. What is it? 0. So P of minus 2 is equal to 0 is the condition. This is the condition. This is the condition. Once you write that condition, then you will substitute. Under P of minus 2, you will you'll express that. That is in this one, wherever there is x, you will use minus 2 is equal to 0. So on solving this, you can find the value of m. Online students? Got it? Finished?
Yes, ma'am.
All right. Now, what must be added to f of x so that the resulting polynomial is divisible by g of x? What should be added to f of x so that the resulting polynomial is divisible by g of x? So that means f of x is not divisible by g of x. Let's take a number first. Now, supposing you divide 38 by 5. 5 sevens are 35. What's the remainder? 3. Now, 38 is not divisible by 5. What should be added to 38? What should be added to 38 so that the resulting number is divisible by 5 is the question. So you must write the answer using some number here in the presentation. I'll tell you again, see here. Now the question is 38 is not divisible by 5. Now when you divide, what do you get? 5 sevens are 35, 3 is a remainder. So you get quotient 7, remainder 3. Using the numbers here, you should answer the question. Using the numbers here. Now the question is 38 is not divisible by 5. What is the number that should be added to 38 so that the result is divisible by 5? So see the remainder. What is the remainder? 3. Add minus 3. Add the negative of the remainder. See, I'm saying you can give different answers, but you should answer using the number, using a number here in the division process. So use a remainder. If you add 3, it will become what? 38 plus 3, 41, not divisible. If you add minus 3, it will become 35, and 35 is divisible by 5. So when the question is what is to be added, the negative of the remainder is to be added. If the question is what is to be subtracted, the remainder has to be subtracted. If the question is what is to be subtracted, remainder has to be subtracted. See, 38, what should be subtracted? The remainder 3. It becomes 35. What is to be subtracted? Remainder as it is should be subtracted. What is to be added? The negative of the remainder should be added. To 38, what should you subtract? Subtract the remainder 3. So you get 35, and 35 is divisible by 5. But what should you add to 38? The negative of the remainder. Then only you get 35, which is divisible by 5. So remember like this, if the question is what is to be added, the negative of the remainder is to be added. What is to be subtracted? The remainder only should be subtracted. So you can make a note of that. Have you taken out the question? No? Okay. Have I mentioned here? Yeah, done, children. So what is the question here? What must be added so that the resulting polynomial is divisible by g of x? What is to be added to f of x? So that means now f of x is not divisible by g of x. It's not exactly divisible. There is some remainder. So what should be added? Whatever remainder you get, the negative of the remainder should be added. Okay. Let's perform the division process. Now you know how to divide. You have to do the long division here. To answer this question, you have to perform the long division. To answer this question, you have to perform the long division. So what will be the first term? 4 to the power 4 divided by x squared. I'll send the image, you work it at home. Now we'll just do it together in the class. So what is it? 4x squared, correct? So that will be the first term here, correct? Then next what? No, next. Yeah, what do you get? Yeah, that you should write here, right? So 4x to the power 4 plus 8x cubed minus 12x squared. You must write that here. And then change the signs. Change the signs. Minus, plus. Cancels. Then minus 6x cubed plus 10x squared. 10x squared. Okay, then bring the remaining terms. Plus x minus 1. Now what's the next step? 1 minute. Let me ask somebody else. Aragami, what's the next step? Let's see. Six x cubed. Where is 6x squared? Divided by x squared. Minus 6x cubed divided by x squared. What is it? Minus 6x. Minus 6x. That's the next term in the quotient. Minus 6x. Now you should multiply minus 6x with x squared plus 2x minus 3. What do you get? Minus 6x cubed minus 12x squared plus 18x. Write that here. Minus 6x cubed minus 12x squared plus 18x. Change the signs now. So plus 22x squared minus 17x minus 1. Now next what? 22x squared divided by x squared. 22 meaning plus 22. 22 means plus 22. See, actually this rough column you can multiply it directly and write here. Now multiply 22 into x squared, 22x squared. 22 into plus 2x plus 44x. 22 into minus 3 minus 66. Change the signs. Cancels. Minus how much? 61 x plus 65. This is a remainder. Now, how do we know that we have to stop here? Because the degree of the remainder has gone less than the degree of the divisor. How do we know when to stop the division process? The degree of the remainder has gone less than the degree of the divisor. What's the degree of the divisor? 2. What's the degree of the remainder? 1. If it's equal also, you should continue. If the degree of the remainder and the degree of the divisor, they are equal, you should continue. When the degree of the remainder goes less than the degree of the divisor, then you stop. See, here it was equal only, no? See, this stage, 22x square and divided by x square, this one. The degree were equal, 22x square and x square. If it's equal, you should continue the division process. Now you see that the degree of the remainder is 1, but the degree of the divisor is 2. The degree of the remainder is less than the degree of the divisor. So start the division process. So the remainder is minus 61x plus 65. Added. So negative of the remainder. That means change the signs. Plus 61x minus 65. Negative of the remainder meaning change the signs. What should be added? Plus 61x minus 65. What is to be subtracted? The remainder itself. Minus 61x plus 65. What is to be subtracted? This one only has to be subtracted. What is to be added? Change the signs and that should be added. See here, this is the remainder. The question is what is to be added? Added. So the negative of the remainder. See here, minus negative of the remainder. That is plus 61x minus 65 is to be added to f of x so that it's divisible by g of x. All right. So you did not know. I don't know how to answer this question. I don't know how to answer this because I think sometime back I did it on the board. I did it for you, right? We did the long division. I told you that it's of 8th standard. If you have not learned it, we'll do it now. And then I did one sum like that for you. And we got remainder 0, no? You're sitting right in the first bench and what Anirudh, not Anirudh, what's your name? You're saying no. Huh? Didn't we do a division, children? Ah, it's here. No, not this one. Now, class, my question is, didn't we do a division? Hmm? I'm saying in my school they didn't do. Yeah, this one. Sorry? Didn't I tell you first new dividend, second new dividend? Yeah. No. Now, in today's class, sometime back, we did the division, right? No, you have not written it. But I explained the division. Oh, you wrote it also? Okay, fine. I don't know. Today's class, I said you should have learned it in 8th standard. If you have not, let's see the division now. Yeah, then you were not able to say why. See, it's so lame when you talk about school, you know. It's so lame. Didn't we do it now? Yeah, then I did it now. If you didn't understand, you should have asked me. You're saying in school. Now, let's not be childish. In school, they didn't say. In school, they said this. It's so childish when you say that. Don't talk about school here. In school, they said this long division is not needed, is it? In your school? This one. So you don't want to, you don't have to learn. What will you do next year? Next year we have. So you didn't listen to me when I explained. Or if you understood what I said, the long division, children. See, okay, fine. Let me not go into that. Fine. You should know the long division process, children. You must know it. So I was telling you then that if the question is, what is the least number to be, what is to be added? The negative of the remainder is to be added. What is to be subtracted? The remainder itself has to be subtracted. All right. I'll share this image on WhatsApp. It's time, so I cannot continue now. Meaning, I wanted to finish off this presentation, but it's time. All right, children. So that's it for today's session. Thank you so much. Good night. See you. Online students may leave the call. Thank you.
Thank you, ma'am.
Thank you, children. Thank you. Good night.